This bathtub hasn't been properly clean in probably 15 years. I know because I asked the landlord. He said, and I quote, "It's always been like that." Which tells me everything I need to know about the last 15 years of cleaning attempts in this bathroom. I've been seeing videos all over YouTube lately. Same format every time. Guy holds up a white container. $sign in the thumbnail. This $1 powder kills every bathtub stain permanently. Cleaning companies prayed you'd never find this. And look, I get why those videos perform. The hook is good, the promise is compelling, but every single one of them skips the part I actually want to know. Does it work? Not on a slightly dirty tub they staged for the video, on something real, on 15 years of hard water, rust, and whatever else has been accumulating in this drain since the Clinton administration. So that's what we're doing today. I bought the powder. I found the worst tub I could get access to. And we're going to find out if this is a fix or if it's fiction. Before I show you the test, I want to spend a couple minutes on what this stuff actually is, because if you understand the chemistry, you'll understand why it either works or doesn't, and you'll be able to spot when someone's overselling it. This is oxalic acid powder. You'll find it in the paint section at any hardware store, usually labeled as wood bleach or deck brightener. It costs between $1 and $3 depending on the size. It has been commercially available in the United States since 1882. That date is not a conspiracy talking point. It just means this is not some obscure discovery. It's been sitting on hardware store shelves for over 100 years. The chemistry is actually straightforward. When oxalic acid contacts rust, which is iron oxide, it triggers what's called a displacement reaction. The iron atoms, which are bonded to oxygen in the rust, find the oxalate ions from the acid more attractive, so they rebond. They leave the oxygen behind and attach to the oxalate instead. This creates a new compound called iron oxalate. Iron oxalate is completely water-soluble. You rinse it, it disappears, the stain doesn't get scrubbed off, it doesn't get covered up. It gets chemically converted into something that washes away. The same mechanism works on calcium and magnesium deposits, which is what hard water staining actually is. Hard water carries dissolved minerals. When the water evaporates, the minerals stay behind. They bond to the surface. That's the white scale you see around faucets, the yellow film at the bottom of old tubs. Oxalic acid breaks those mineral bonds and puts the calcium into solution so it rinses clean. Now compare that to what a standard bathroom spray actually does. Most products on the cleaning aisle use surfactants, which is a technical word for soap molecules. Surfactants are excellent at lifting surface grime, grease, and loose dirt. They surround particles and float them away with water. That's useful. That's what you want for everyday cleaning. But mineral deposits and rust stains are not sitting on top of the surface. They're chemically bonded to the porcelain or enamel or fiberglass. Soap cannot break a chemical bond. Scrubbing cannot break a chemical bond. You can scrub a rust stain for an hour and it will still be there because you're applying mechanical force to a chemical problem. You need a chemical solution. That's the actual reason oxalic acid outperforms spray cleaners on these specific stains. It's not magic, it's not suppressed technology, it's just the right chemistry for the job. Alright, here's the tub. I'm going to show you exactly what we're dealing with before I touch it with anything. Yellow discoloration running along the entire bottom. This is years of hard water minerals building up layer by layer. A rust ring around the drain where old metal hardware was sitting. Calcium scale around both faucet handles, thick enough that you can feel it with your finger like a rough crust on the porcelain. And a general film across the whole surface that's somewhere between beige and brown, depending on how the light hits it. I want to be clear about what I already tried on this tub. Last week, before filming this, I used a full-size bottle of a name-brand bathroom cleaner. The kind with the blue liquid and the spray nozzle and the label that says cuts through tough stains. I sprayed it, let it sit for 5 minutes like the instructions say, and scrubbed with a brush for about 10 minutes. Here's what I got. The general film on the surface is lighter. Some of the loose grime came off. The tub looks marginally cleaner in the way that any surface looks cleaner after you've scrubbed it. The rust ring? Identical. The calcium around the faucets? Identical. The yellow hard water staining along the bottom? Maybe 5% lighter after half a bottle and 10 minutes of scrubbing. So that's the baseline. That's what $9 and 10 minutes of effort gets you. Now let's do the powder. Gloves on, eye protection on. I want to be very direct about this. Oxalic acid is a real chemical, and it needs to be handled like one. The safety equipment is not optional, and I'm not going to move forward until both are on. If you try this at home, same rule applies. 2 tablespoons of powder into 1 quart of warm water. Stir until it's fully dissolved. You want a clear solution? No undissolved crystals sitting at the bottom. I'm applying with a sponge, working it into all the stained areas. Around the drain, along the bottom, around both faucets. Make sure the solution is actually in contact with the staining, not just sitting on top of dry porcelain next to it. Now, and this is the part that feels wrong but is actually critical, I'm not scrubbing. I'm putting the solution on and walking away. 20 minutes. The chemistry needs time to work. If you start scrubbing, you're physically removing the solution from the surface before the reaction is complete. Let it sit. 20 minutes. Okay. Rinsing now. The rust ring around the drain is gone. Completely gone. I'm running my finger over it, and the surface is smooth porcelain. No residue, no ghost of the stain. The calcium around the faucets. Gone. I can feel the difference with my finger. The rough crust has disappeared and the surface is smooth again. The yellow along the bottom is substantially lighter after one application. Not completely gone, but maybe 70% improvement on the worst areas in a single pass. That's the result. 20 minutes, approximately 30 cents of powder, no scrubbing. For the bottom staining, I'm going to do a second application, slightly stronger, 3 tablespoons per quart, and let that sit for another 20 minutes. This is normal for severe buildup. 2 passes gets you where 1 pass gets you most of the way. Second rinse. That's what I wanted. The bottom is clean. Total time, 40 minutes including both applications. Total cost, under $1. Let me be honest with you about what this does and doesn't do, because the videos I've been watching overstate the case in a few specific ways, and I want to set accurate expectations. What oxalic acid genuinely handles well? Rust stains, hard water deposits, calcium scale, iron discoloration, mineral buildup of any kind. If the stain is mineral-based, the chemistry works exactly as described. This is where the product earns everything people say about it. What it won't fix: soap scum, mold, mildew, biological staining. Different chemistry, different solution required. Oxalic acid targets mineral bonds specifically. If your problem is soap scum or mildew, you need a different product for that. Physical damage to the surface, chips, scratches, worn enamel. This powder does nothing for that. It restores the chemical state of the surface, not the physical structure. If your tub looks dull because the enamel has worn thin from years of abrasive cleaners, the powder will clean it, but it won't restore the shine to damaged enamel. Extreme long-term buildup. Plan for 2 applications if you're dealing with something that's been neglected for a decade or more. 1 application will get you most of the way there. 2 applications will finish the job in almost every case. Now safety, and I'm going to spend more time on this than the other videos do, because they mostly treat it as a disclaimer they have to get through. Oxalic acid is toxic if ingested. It can cause skin irritation and eye damage on contact. Rubber gloves and eye protection every single time. Not most times, every time. Work in a ventilated space, open a window, or run the exhaust fan. Never mix it with bleach or any other cleaning chemical. Mixing acids with bleach can release chlorine gas, which is genuinely dangerous. Rinse every surface thoroughly after you're done. You don't want residue left on a surface that someone's going to touch or a pet's going to walk across. Store it in its original labeled container, out of reach of children. None of that is complicated. All of it is important. Here's the thing that actually bothers me about this situation. Oxalic acid is not obscure. Professional cleaners have known about it for decades. Hotel housekeeping departments use oxalic acid solutions to restore bathtubs between guests. Marine restoration crews use it to strip mineral deposits from fiberglass. Woodworkers use it to bleach water stains out of lumber. Industrial cleaning operations buy it in 55-pound bags because nothing else is as cost-effective at scale. Everyone who cleans professionally knows about this product. So why doesn't the average homeowner walk into any supermarket? The cleaning aisle is 50 feet long. There are hundreds of products. Spray bottles in every color. Foam formulas, gel formulas, trigger sprays, pump sprays. Products for bathroom, kitchen, shower, tile, grout, chrome, porcelain, fiberglass, products that claim to cut through soap scum, dissolve mineral deposits, eliminate odors, leave a protective coating, repel future staining. Oxalic acid powder is not in that aisle. It's in the paint section, in a plain container, next to the deck stain. That's not an accident. The household cleaning products market generates over $200 billion in global revenue every year. The companies that dominate that market, the ones with 50 feet of shelf space in every supermarket in the country, built that business on one principle: repeat purchase. Every product on that shelf is designed to manage your problem, not eliminate it. A spray that lifts surface grime today means you need to buy another bottle next month. A foam that temporarily brightens your tub means you're back in the cleaning aisle in 3 weeks. A $2 powder that solves the mineral staining problem permanently will need one application, problem gone, don't need to buy it again for a year, generates $2 of revenue total forever. From that customer, you cannot build a $200 billion industry on products that make themselves unnecessary. So the industry doesn't sell those products, they sell you the management solution, not the permanent one. They sell it with bright packaging and celebrity endorsements and scientific-sounding names. They make the aisle so crowded and so loud that a plain white container of oxalic acid powder on the bottom shelf of the paint section becomes effectively invisible. That's not a conspiracy, it's a business model. A completely rational, completely legal business model that happens to cost the average household several $100s a year in products that mostly don't fix the problem. I'm not angry about it, I'm just telling you how it works, so you can make a different decision. Next week, I'm testing the $3 rock chip repair liquid that's been all over the algorithm lately. Claims to fill windshield damage permanently at home. No dealer visit, no replacement, just a small bottle and 10 minutes. I've already run the first test. I'll just say this, the results were more complicated than the thumbnail suggested. I want to do a second test before I give you a verdict, because I think there's more to this one than a simple fix or fiction answer. That video goes up next week. If you don't want to miss it, subscribe, that's the whole pitch. I test these things properly so you don't spend money finding out the hard way. Fix or fiction. See you next week.